Good morning, good afternoon. 8.2 multiplying and factoring, also known as multiplying and dividing polynomials. Multiplying a polynomial by a monomial, like this polynomial by a monomial. You are going to distribute the monomial to each term in the polynomial. Right answer in simplified standard form. So this is the main reason why we did those exponent rules, because when you're multiplying something like this, n to the first times n to the third, you have this like bases raised to a power. You're multiplying them. What do you do with their exponents? You add their exponents. So those are the rules you have to remember. And then 5 and 3. So I'm going to distribute this. 5 times 3 is 15. This becomes n to the fourth. 5n times a negative n to the second. So this is a negative 1. So it becomes a negative 5n to the third. And then 5n times 8 becomes a positive 40n. Remembering to add these exponents and multiplying the coefficients. Okay, so here, this one, we have 2n to the second multiplied by this whole polynomial. So, distributing this here, multiplying the coefficients, so 2 times 8, and then n to the second times n to the fifth is now n to the 7. Negative 2 times 2 is a negative 4. Again, adding the coefficients, adding their exponents would be to the 6th power. 2 times 5 is positive 10, and then it becomes n to the 4th power. I'm multiplying like bases. N is my base, so I add their exponents. And then 2 times a negative 9 becomes a negative 18, and then that n to the 2nd power. It's written in standard form because 7 is the biggest exponent, 6, 4, 2, written in descending order. Remember, it does not matter what the coefficient is. You have to go off of the degree or the exponent. Okay, let's do one more. I can get that out of there. Now I have one variable here, two variables here, but one variable here. Again, I'm going to multiply my coefficients. So 30, x to the second times x to the second becomes x to the fourth, and y to the third just stays there. Okay, negative 7 times 3 would become a negative 21, x to the second, because there's no x to the second, or no x to the second to multiply, and then y to the third times y to the third becomes y to the sixth. Okay, 3 times a positive 9 becomes positive 27, and then x to the second times x to the fourth becomes x to the sixth, y to the third times y to the eighth becomes y to the 11th. And then I have a negative 7, so a negative 21 again, x to the second, y to the third. Again, I want to write this in standard form. So my biggest polynomial, or my biggest degree, so this is only to the 7th degree. This is my monomial. Remember, when I have 4 and 3, I would add them together. So this is to the 7th degree. This one is to the 8th, this one is to the 17th, and this one's to the 5th. So I'm going to write to the 17th first. So 27, x to the 6th, y to the 11th. I said 8th, right? So minus 21, x to the 2nd, y to the 6th. This one was 7, so plus 30, x to the 4th, y to the 3rd. And then my last one, minus 21, x to the 2nd, y to the 3rd. Okay, now when finding the greatest common factor, find the greatest common factor, GCF. So to find the GCF, okay, so find the GCF of all the coefficients. Gosh, coefficients and constant terms. Okay, and then write this out in this. Okay, so what this means is, first, if you have a constant, you're not going to be able to, a constant is just a number, you're not going to be able to factor out a variable because a constant doesn't have a variable, so therefore you can't factor out a variable. So you want to divide each one of these by the smallest thing that you can, the biggest thing that you can, but you're going to have to look at the smallest thing. So first, looking at the variables, you're going to look at the smallest degree of variable. So here I only have x to the first, so the most I can take out of all of them is x to the first. Because if I take out x to the second, that would make, it's too big. I wouldn't be able to take x to the second out of this one here. I also want to look at my coefficients. Okay, sorry, I was interrupted, so I don't know exactly where my train of thought was going, but I want to factor out, I have the factors of 3 are 3 and 1, so 3 can be divided out of each one of these. So my greatest common factor is going to be 3 and then x. So I'm going to factor that out, and there's going to be some stuff left. So I have to think about this. I'm dividing each one by 3x. So 3 divided by 3 is 1, and then x to the fourth divided by x. Remember, like terms, dividing like terms or like bases raised to powers, I'm going to subtract their exponents. So 4 minus 1 is 3. So I'm left with 1x to the third. Negative 9 divided by 3 is a negative 3. X to the second divided by x becomes just x to the first, because 2 minus 1. Negative 12 divided by 3 is a negative 4, and then x to the first divided by x to the first is just x. Alright, I don't remember again where I was, so I'm just going to go to the next problem. This is, I factored out the greatest common factor. Let's just pull out first the looking at all of these and what is figure out what is that greatest common factor. So of this one we have 15 x to the fourth. 15, 20, and 60 can all be divided by 5, right? Because the factors of 15 would be 1, 3, 5, and 5 can go into this one, and 5 can go into this one. So 5, and then x would be to the smallest one. So greatest common factor is the variable of all the terms, and the smallest degree of that variable, and then the number is going to be of all the numbers. So 5 can go into 15, 20, and 60. X to the second can come or factor out of all of those, or can go into all of those. So if I were to factor it out, I'm going to divide, and I think the next part of our notes down here is we're supposed to be doing this part down here. So the first part we're just going to be figuring out what the greatest common factor is. So 5x squared. And then here we have 60, 20, and 6. Again, 6, looking at 6, I can take 6 out of that one and this one, but 6 can't go into 20. So I would say 3 would be the next biggest one. So 3. And here we have end of the 4th, end of the 5th. We have an X in this one and this one, but not in all of them. So really, I can only take out n to the 4th. So that would be my greatest common factor. So then here, this is now factored form of a polynomial. You're going to find that greatest common factor of the polynomial. You're going to factor the greatest common factor from each term in each polynomial. So factor out, I like to say a lot, the greatest common factor from each term in the polynomial. Then you're going to write your answer with the greatest common factor, kind of like I was doing up there, in front of the remaining polynomial, written in standard form always. So looking here, our first problem, 3x to the 4th, and this is the one I did already. This is the one I did up here. So 3x is going to be our greatest common factor. I'm going to write it out front, and then this is the, I can factor out the 3x out of all of this, and then this is my new polynomial written in standard form. Okay, this one, this one's complicated. So let's get that out of there. Go. All right, so 9, 15, 27, and 30 can all be divided by, can't all be divided by 9, but they can all be divided by 3. And then I have x in all of them, but my smallest x would be x to the first, not smallest, but x to the first. And I have n in all of them, but I only have an n to the first here, so you're going to be dividing out all of them by 3, x to the first, n to the first. Blah, blah. So this one, remember you're going to divide 9 divided by 3, which is 3. X to the 7th divided by x would be x to the 6th. Remember, 7 minus 1. And then n, 3 minus 2. This one, 15 divided by 3 gets me a negative 15. So I get a negative 5. X to the 5th, subtract the 1. So x to the 4th, n divided by n goes away. Negative 27 divided by a positive 3 is a negative 9. X to the 1st divided by x to the 1st goes away. N to the 5th, n to the 1st becomes n to the 4th. And I'm running out of room. 30 divided by 3 is a positive 10. X to the 4th, n to the 1st. Okay, now I want to remember to write in standard form. Standard form is written when they're in descending order and in alphabetical order. So here, this monomial is 8th degree. So this is going to go first. These two are both to the 4th degree, but we want to put in alphabetical order. So we're actually going to switch those. So everything else, that's the 5th. Actually, we're going to write this one first because this is 4th and 1st. So we have 3x to the 6th, n to the 2nd. Sorry, that's first. This one is to the 5th degree, so it's 10x to the 4th, n to the 1st. Then this one we want to write, and we want to write this n first, but that's, you know what, I'm not going to worry about it. n to the 4th minus x to the 4th. Okay. And our last one, and we will not have time for this, so we will, hold on, I'm going to pause it. It's going to be quick, I'm really sorry. Okay, when you have to figure out the square minus the circle, the area of the square minus the area of the circle. Area of the square is 6x times 6x, which equals 36x squared. pi r squared equals this. I'm going to factor out that 9x squared, which leaves me with this.